So Bayes' theorem is probably the most difficult thing that we are going to be learning up until this midterm exam. Bayes' theorem is a method of revising probability given that additional information is obtained. So when we're looking at Bayes' theorem, we're looking at two mutually exclusive and collectively exhaustive events. And when we're talking about Bayes' theorem, there's a couple of definitions that we need to have before we start writing the formula and going through the example. So Bayes' theorem has to do with prior and posterior probabilities. A prior probability is going to be my initial probability based on the present level of information. These definitions are going to make a little bit more sense once we do an example. A posterior probability is a revised probability based on the additional information that you've been provided. So let's put the formula down, but it's not going to make a ton of sense until we do our example. But let's have the formula in our notes before we jump into it. So the Bayes' theorem formula states that the probability of some event AI given B happening is equal to the probability of that event AI times the conditional probability of B happening given that event AI divided by the probability of A1 times the probability of B given A1 plus the probability of A2 times the probability of B given A2. So let's jump into an example because it doesn't make a heck of a lot of sense until we do an actual example of it. So we're told that 5% of the population of human has some disease. So we're told the probability of A1, them having the disease, is equal to 0.05. The probability of A2, the person not having the disease, is just that complement rule, right? It's 1 minus 0.5, so it's 0.95. We are given the following conditional probabilities. We're told that there is a test out there. So the probability of this test showing positive and you having the disease is going to be 90%. So this is the test shows disease and is correct. Now there's also a false positive in these tests, right? The false positive showing that you have the disease when you don't have the disease is going to be 15%. And so now we're asked, what is the probability of someone who tests positive and actually has the disease? So somebody who tests positive and actually has the disease. So the probability of A1 given B. So this is called our posterior probability because it's our revised probability based on the additional information. And so we're going to use this formula up here. We have all of the information that we need to calculate this. So we're going to have the probability of A on top, 0.05. Actually, let's do this in white. So 0.05 times the probability that you have a correct positive, right, which is going to be 0.90. And then we're going to divide this whole thing by that same 0.05 times 0.90, and then plus 0.95 times that false positive rate. And so when we calculate this out, we end up with 0.0450 divided by 0.1875, which gives me a probability of 24%. So the probability that a person has the disease given that they tested positive is 24%. Questions on Bayes' theorem? I'll put another explainer video over the weekend out because this is a little bit difficult, so I'll walk us through when we're not at the end of class and we're not so rushed. Okay.